these are some examples of the homework that you're doing tonight. I know that the first problems, 9 and 13, they just asked you to use long division. I did synthetic division because I wanted to show you and give you some practice on how to do synthetic division. So if instead of long division you did problem 13 with synthetic division, you would set it up in the synthetic division in this format with this, the T-table kind of looking thing with the coefficients. You've got x minus, you've got the place for your remainder and the plus sign. You're dividing by -2. I know it says x plus 2, but remember this is supposed to be x minus your a, so it's going to be x minus -2. So that's why down here we have -2. Bring down the 3, multiply the 3 times the -2, put it in the next column, -6. Add those together, you get 3. Multiply that by the -2 and put it in the next column, which is -6. Add the -6 and the 8 and you get 2. Multiply the -2 times the 2, put it in the next column. Add the 4 and the -4 and you get 0, which makes us happy because it means we have no remainder, and it means that these are the coefficients for the second degree polynomial or quadratic. Because the original polynomial was a third degree, what we're left with is a polynomial of second degree. And that's the answer. In problem number 27, please note that this is, x cubed. So there's something important we have to do first. We have to rewrite that so that all of the degrees are accounted for. And I'm going to use synthetic division again, but this is not going to be x plus 3, but x minus a -3. So we have it set up. We're using all of the coefficients, and our divisor being -3. Bring down the 1, multiply by -3, add those together, get -3. Multiply times -3 and you get +9, add those together, you get +9. Multiply by the -3 and you get -27, add those together and you've got 0. So there's no remainder, and therefore these are the coefficients for a polynomial 1 degree less. Since this was a third degree polynomial, this is going to be a second degree polynomial. And there it is. So we've got our answer. Now I skipped ahead to number 33. I'm going to go back to 29 in a minute, but went to 33, and it's saying to find your P of A using the remainder theorem. Well, what that means is that if we were to plug in a value into a polynomial, when we evaluate it, that's going to equal the remainder as if we divided by x minus the a. So I'm going to use synthetic division and do this. And when I take the polynomial, I shouldn't say P of A, I should say P of X, sorry. Hold on a minute. Yeah, so this is saying when there is a polynomial, P of X, we divide it by x minus A. And when we do that, the remainder that we get from this division will be the same thing as if we had put this A in there. So we're going to take that polynomial and we're going to divide it by x minus -2, because this -2 was our a, and that's going to find our, and we find the remainder and we'll have it. So synthetic division. Why do I have a 0 there? That's a good question. Why is this there? Because look at the degrees. I have third degree, second degree, first degree. I don't have the 0 degree. So I have to say that the coefficient for the third degree is 1. The coefficient for the second degree is 4. The coefficient for the first degree is 4. And the coefficient for the 0 degree, which does not exist here, would be 0. So we have all of our degrees accounted for. And we're dividing by -2. That's our A. And so we do our synthetic division. And we get a remainder of 0. Well, what that means is what's in the remainder box. This is our P, our polynomial, evaluated at -2 using this divisor. So that's telling us, oh, if we just plugged in -2, we would have got it. So let's check to make sure that's true. Let's actually put in -2 into the polynomial and see what we get. Well, we get -8 plus 16 minus 8. Well, that's 0. And sure enough, they're the same thing. Now, what this is for is it's not that necessarily that synthetic division is easier by doing this synthetic division than just plugging in the value. It's just showing you that there's another tool, because sometimes we're going to have harder polynomials, and it might be easier to do the synthetic division than it is to plug in a value for it. So it checks. Now I'm going back to problem number 29. And in problem number 29, what we want to do, the process there is we're going to divide the polynomial by that one factor, x plus 1, and then look at the second degree polynomial that we have left, the quadratic. And so we have our polynomial that we're going to divide by x plus 1. We set up our synthetic division, and we start doing our synthetic division, and we get no remainder, which is great, which means we have a quadratic there, x squared plus x minus 6. And that means we can factor that one, x plus 3 times x minus 2. And then we have this thing going. Don't forget that x plus 1 was a factor. So since x plus 1 is a factor and these are factors, we have to put it all together. And so we have to bring that x plus 1 down there. And so now we can see that that's the full answer of this third degree polynomial has been factored to these three factors. Number 47, I think this is the last problem. I'm not sure. Maybe, I think I have one more. No, I think this is the last one that I did for you. Notice here in this problem, this is x cubed minus 1. You can't use synthetic division because synthetic division has to be just x to the first minus a constant. So we're going to have to do long division. Note that I had to put this 0 in for a placeholder there. So we're going to do our long division, subtract that and bring everything down, and then we notice we have to multiply by 4, and we subtract all that, and we have nothing left. And so therefore, when we do this division, we get the answer of x plus 4. That's what's up here when we did the long division, x plus 4. So our answer is x plus 4. That's the end. So I'm going to post these so you have these to look at. Remember that the quiz tomorrow has just synthetic division on it. That's why I did several problems with synthetic division.